Okay, so good day everyone. For today, I want to learn about the permutation of distinguishable objects. Okay, so the number of permutations of n objects, where A objects are alike, B objects are alike, and C objects are alike, and so on is given by this formula. N factorial all over A factorial, B factorial, C factorial. So this A factorial, B factorial, C factorial are those objects that occurred how many times or that had the so-called repetitions. Okay, so example. Find the number of distinguishable permutations of the letters in the word basketball. As you can see, repetitions of B, repetitions of A, and even L, manifested. So the solution would be let A be the two or the twice occurrence of B. Let B be the twice occurrence of A. Let C be the twice occurrence of L. So all in all, we have how many letters we have? We have 10. So total number of letters. Note, include only letters or objects that appeared more than once. So by the formula n factorial all over A factorial, B factorial, C factorial, upon substitutions, is equal to 10 factorial all over 2 factorial times 2 factorial times 2 factorial. Upon getting or upon evaluating, 10 factorial is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So the denominator 2 factorial is 2 times 1, and 2 factorial also 2 times 1, and the other 2 factorial is 2 times 1. So you cross out 4 by the 2 appearance of 2. Okay, then 2 times 1, so will give us, so you cross out or reduce, so will give us 453,600 permutations. So cancel out common factors or reduce. Okay, so the best word here is reduce. So 453,600. Okay, then we also have, we go with the circular permutations. The circular permutation, the different possible arrangement of n objects in a circle where the arrangement is distinguishable clockwise and counterclockwise rotations. So the formula would be the quantity of n minus 1 is equal to the quantity of n minus 1 times the quantity of n minus 2 times the quantity of n minus 3 dot times 2 times 1. Otherwise, arrangement in a queuing in the like, the quantity of n minus 1 factorial all over 2 is equal to the quantity of n minus 1 times the quantity of n minus 2 times the quantity of n minus 3 times 2 times 1, all over 2. So example, how many ways can 5 persons be seated around the circular table? Solution would be n is equal to 5 since 5 persons. Since n is equal to 5, upon substitution, the quantity of n minus 1 factorial is equal to the quantity of 5 minus 1 factorial. So operate first the numbers inside. 5 minus 1 is equal to 4, then copy the factorial sign. So upon evaluating, 4 factorial is 4 times 3 times 2 times 1 will give us the product of 24. So how many, going back to the question, how many ways can 5 persons be seated? There are 24 ways can 5 persons be seated around circular table. So that's the answer. So then we also have example number 2. In how many ways can 5 keys be arranged in a keyring? Since there are 5 keys to be arranged in a keyring, then the quantity of n minus 1 factorial all over 2 is equal to the quantity of 5 minus 1 factorial all over 2. So 5 minus 1 factorial is equal to 4 factorial, and copy the denominator 2. So is equal to, on evaluating, 4 factorial is 4 times 3 times 2 times 1, and you copy the denominator 2, so you cross out. So the remaining numbers in the numerator is 4 times 3 times 1, So we'll give you 12 ways. So how many ways can 5 keys be arranged in a queue ring? 12 ways. Okay, can 5 keys be arranged in a queue ring? Okay, so that's it. Then, okay, example number 3. Out of 8 textbooks, Patrick can only put 4 textbooks in his bookshelf. In how many ways can he arrange these books? Okay, solution would be our n is equal to 8. Since the presence is 8, how many textbooks? 8 textbooks. Then, okay, r is equal to 4 because Patrick can only put 4 textbooks at a time. So 8p4 is equal to 8 times 7 times 6 times 5. Okay. So I have also a shortcut here, but yeah. Taking 4 consecutive factors starting with 8, that is 8 times 7 times 6 times 5. So will give us the product of 1680 ways. That's it. Then example number 4. If 7pr is equal to 840, what is r? So here, okay, the value of r is missing. Okay, so solution 7pr is equal to 840. So n is equal to 7. So 7pr is equal to 7 factorial all over 7 minus r factorial. So 840 is equal to 5040 all over 7 minus r factorial. So by cross multiply, 7 minus r factorial times the quantity of 840 is equal to 540. 5040. So divide both sides by 840. So 7 minus r factorial is equal to 5040 all over 840. So 7, the quantity of 7 minus r factorial is equal to 6. Express 6 as factorial notation. 6 is equal to factorial. So the quantity of 7 minus r factorial is equal to 3 factorial. Cross out the factorial. So remove factorial symbol. So solve for r. 7 minus r is equal to 3. Then 7 minus 3 is equal to r. So r is equal to 4. Okay. Then okay, example number 5. Okay, example number 5. If np3 is equal to 720, what is n? Okay, so you have the value of r, which is 3. The missing one is the n. So solution np3 is equal to 720. R is equal to 3. As you can see, r is equal to 3. So np3 is equal to n factorial all over the quantity of n minus r factorial. 720 is equal to n factorial all over the quantity of n minus 3 factorial. So here below, okay, here as you can see, okay, so express n factorial as factor. So n times the quantity of n minus 1 times the quantity of n minus 2 times the quantity of n minus 3 is equal to 720 all over the quantity of n minus 3. You cross out since they are similar. So the quantity of n is equal to the quantity of n minus 1 plus the quantity of n minus 2 is equal to 720. We can use whatever convenient and appropriate method in solving for the value of n in the equation. However, this may take a lot of your time since the degree of the polynomial equation is